Welcome. In the world of web development, a critical challenge arises when we build applications that need to perform heavy tasks like video rendering or, in our case, AI processing. In a traditional setup, if a user asks the server to process a complex task, the server effectively freezes for that user until the task is done. This synchronous blocking causes high latency and, if enough users join, can crash the entire system. To solve this, our group has implemented a hybrid cloud application using an event driven architecture. This approach allows us to decouple the user's interface from the heavy backend processing, ensuring that the app remains fast and responsive at all times. Now let us examine our architecture diagram. We have divided the system into two distinct worlds, the front-end web tier and the serverless backend. On the left, we have the user interfacing with our Amazon EC2 instance. This acts as our front door. When a user submits a note for AI summarization, the EC2 instance does not process the data itself. If it did, it would be unavailable to handle other users. Instead, the server performs an asynchronous handoff. It saves the essential data and immediately hands a notification to Amazon SNS, which acts as a message broker. This allows the EC2 server to send an immediate success response to the user. From the user's perspective, the upload is instant. On the right side of the diagram, the message broker triggers the backend worker, an AWS Lambda function. This function operates independently of the web server. It wakes up, retrieves the note, communicates with the Gemini API to generate the summary, and updates the database. This architecture provides two major benefits. Firstly, scalability. The web server is never bogged down by heavy tasks. We could have 1,000 users submitting notes and the interface would remain smooth. Secondly, resource efficiency. We are not paying for a massive server to sit idle. We utilize compute resources only when a specific event occurs. Now, Chrislin will break down the specific AWS services we used and explain what they actually do.
To build this architecture, we integrated 5 distinct AWS services. I want to explain what these services actually are using simple analogies and then explain their role in our stack. First, we used Amazon EC2 or Elastic Compute Cloud. Imagine EC2 as a personal computer that you rent, but it physically lives in an AWS data center. You have full control over it. You can install software, change settings, and run code, just like on your laptop. We are using this virtual computer to host our Python Flask application. It runs 24/7 to serve our website to the users. Next, for files, we used Amazon S3 or Simple Storage Service. Think of S3 as an infinitely expandable hard drive or a secure, programmable version of Google Drive. Instead of saving files on the web server itself, which can run out of space, you throw them into the S3 buckets. We offload all the user uploaded images to S3. This keeps our web server lightweight and ensures our data is safe and durable. For our data, we chose Amazon RDS, the Relational Database Service. Imagine a complex Excel sheet or a SQL database, but instead of running it on your own computer, where you have to worry about backups and updates, AWS manages it for you. It is a dedicated server just for structured data. We run a PostgreSQL engine here to store the node titles, text, and the final AI summaries. Finally, the services that make our app smart, SNS and Lambda. Amazon SNS is like a digital courier service. Its only job is to take a message from point A, that is our server, and guarantees it get delivered to point B, our worker. It decouples the system so they don't have to talk directly. AWS Lambda is perhaps the most unique service. Imagine hiring a contractor who sits at a desk sleeping. They only wake you up when you give them a specific job. They do it in milliseconds and then go back to sleep. And you only pay them for the seconds that they were awake. Lambda is our background worker. It wakes up only when SNS triggers it, calls the Gemini AI, saves the data, and shuts down. This makes it incredibly cost effective compared to running a second server.
Hello guys, today I'll showing you the live demo for the 3-tiered application that we have made on AWS. So this is the application we have made, which is actually hosted on a EC2, and you can see the IP is of an EC2 instance. Then the main Flask application is running on the EC2 instance. You can also see the test node which you have uploaded beforehand, and you can see the original text as well as the Gemini summary of it. Now I'll show you the RDS database of it. So you can see in the database, the only single node, the test node, is visible. But if I try to see the node with the specific title as live demo, you will see that there is no such node. But now in the demo, we'll create a new node with the title live demo. I'll also like to show you the S3 bucket. Here we can see that there are no images uploaded here right now. As you can see, there is no images, but we'll upload it to it later. You can also see there is no CloudWatch Logs for the Lambda, and there is no Gemini API call. Now I'll create a new node. I'll name it live demo. I'll paste some text into it. I'll choose a file and I'll upload it over here. Now once I post it, the Lambda will be called, which will call the Gemini API. And after some time, that will analyze and send back the response to the EC2, which will then update the RDS database. As you can see, the website is refreshed, and I can see my note has been uploaded with the Gemini summary coming up as well. You can see the image is the same one which you uploaded, and you can also see the original text and the Gemini summary of it. Now I'll show you the database changes which have happened. Now when I go to the database, you can see that for the live demo title, the new node has been added, and for all nodes, the 2 nodes are visible. Now in the S3, you can see that the EC2 instance has uploaded the correct image that we wanted. You can see that the S3 is acting as the data storage layer, independent from EC2. And you can also see that the Lambda has been called and the Gemini API call has been successful in the log events of the CloudWatch Logs. So in this way, we have created a multi-tiered application which uses different services like EC2, S3, RDS. Thank you for watching this video. I hope you liked it.